Okay, this is Algebra 1, Semester 2, Unit 7. This is 8.3 and 11.3 extra. Or extension, I guess it is. Okay, our first question here. Can you simplify simple rational expressions with negative exponents? Well, first thing that we need to understand what causes a negative exponent. So we have x times x, if we expand it from our last lecture, x times 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 x. There should be 10 x's down here. Okay? And when we cancel these with the like factors, we end up with 8 x's on the bottom. So it would be x to the 8th under 1. Now, if you were to subtract, as we discovered occurs, to get the same answer, we would have 2 minus 10, which equals x to the negative 8th. So that tells us x to the negative 8th is equal to 1 over x to the 8th. So those are two different ways of expressing the same thing. Usually in math, we do not like having a negative exponent as an answer, so we turn it to positive. In addition, when dealing with exponents, we don't like to deal with negative exponents. So keep that in mind. Here we have x squared over x to the 3rd times x to the 1st. So we have x squared, and this would be 4 x's on the bottom. We expand that out, and we cancel our like factors, and we end up with 1 over x times x, which is x squared. Now another way to write that is x to the negative 2. I want you to write them both, just for right now to make sure that you understand that. X to the negative 8th, we already saw from the first one, is equal to 1 over x to the 8th. Okay? If we have 1/4 to the negative 3rd, we can't really do anything as long as that's a negative. So, in order to deal with that negative, let's go ahead and pull the parentheses off. We know that would be a 1 to the negative 3rd over a 4 to the negative 3rd. Now, because that's a negative, flip that one to the bottom to make it positive. At the same time, we can flip that one to the top to make it a positive exponent. So we have a 4 to the positive 3rd over 1 to the positive 3rd. That would make 4 times 4 times 4 over 1 times 1 times 1, which is 64 over 1, or 64. Okay? Another way to look at that is 1/4 to the negative 3rd is equal to 4 over 1 to the positive 3rd, which equals 64. 0 to the negative 7th, that would be 1 over 0 to the 7th. Because we can't have 0 on the bottom of a fraction that's undefined, we write undefined for that answer. Be careful of that one. Now, any number to the 0th power, that would be like if we had, let's say this was negative 1, or negative 3 to the 1st over negative 3 to the 1st. It really does mean that we have one factor that's canceling. A negative over a negative would be positive, so that equals a positive 1. Negative 3 to the 1st minus 1, like that, equals negative 3 to the 0th. Anything to the 0th power equals 1. Anything. Okay? Here we have x to the 6th times 4. Now take this x to the 6th and put it on the bottom because it has a negative exponent. Now we have x to the 6th times 4 over x to the 6th. The x to the 6th will cancel and we simply get 4. This one, please expand it out. 5 into the 6th. Now we could go ahead and combine these ends here. There's 2 there and there's 4 there, so that will be into the 6th. 5 into the 6th, into the 6th, 5 into the 6th, over into the 6th. Now you might say, can't we cancel the into the 6th? Absolutely. They're top to bottom and they're factors. So all that we have left is 5 times 5 times 5. You should have that memorized. 125. 4 to the negative 3rd. We need to make that into a positive exponent, so we would do that by flipping it to the other side of the fraction. That would equal 1 over 64. That x to the negative 4th needs to be brought to the top. That's an x to the 1st that's up there. So it'll be x to the 1st times x to the 4th. Expand those out, we'd find that we have 5 x's being multiplied together. Okay. Again, we see from our very first one that we did earlier that when we have a negative exponent out there, we can bring it in. Distribute it into each denominator and numerator. Now that would cause us to flip the 2 to the bottom and the 5 up to the top. And now expand them out. And we find that we have 125 over 8. Moving on, we're going to look at radical expressions. These are roots. I look at a square root like a prison. And the only way to get out of a square root prison, which is a prison that has no numbers written out here in the corner, is that you can only get a factor out if it occurs twice. In other words, if there's twin factors, you can wipe them out and one of them gets out of prison. One of them gets eliminated, but one gets out. And we always want to free the prisoners. I will probably tell you a story in class about a man that freed a bunch of prisoners out of Vietnam. And you always want to be like he was, very heroic, and get everybody out of prison you can. So our first trick here is to factor this down. You could use any factors that equal 60. I'm going to use 6 and 10. They came to mind. And 6 breaks down to 2 and 3. Circle the primes, 2 and 5. Now I write those primes back inside that prison. 2 times 2 times 3 times 5 is equal to 60. Because I have 2 2's, I can wipe them out and write one of them outside the prison. I don't have 2 3's, so it has to stay in prison. I don't have 2 5's, so it has to stay in prison. So I go 3 times 5 is 15. That's how I get that answer. Now over here, I have 8. 8 breaks down to 4 and 2. 4 is 2 and 2. So 8 is equal to 2 times 2 times 2. I can only get my pairs knocked off. So one of them gets out, one of them is eliminated, and then there's a 2 left in there. 201 is divisible by 3. The way that I know that is because 2 plus 0 is 2 plus 1 is 3. Because 3 goes into 3, I know that 3 will go into 201. So 3 goes in there 67 times. Now 67 is prime, so I can't take anything into there. So that means that everything has to stay in that prison. Your whole goal is simply to get the prisoners out that you can get out. And if you can't get any out, then you leave it. Which integer is closest to the square root of 5 to the third? Well, what is 5 times 5 times 5? That would be 125. Well, if we think back to the list that I gave you at the beginning of this unit, you know that the square root of 9 is equal to 3, square root of 64 is equal to 8, square root of 121 is equal to 11, and the square root of 15 is 225. So the one that's closest would be 11. Okay, next one. And these are off standardized tests, just sample tests so that you can see how they ask questions in these. The value of 3 times the radical, 180, is between what two integers? Well, let's see if we can break down 180 would be my initial guess here. Actually, I wouldn't do that. I would take the 3 and put him back in prison probably. And if he goes back in prison, he's going to have a twin. So it would become 3 times 3 times 180, or 9 times 180, which equals 0, 1620. So what this actually equals is a radical 1620. Now there's a lot of ways to do this. Here's the reason I did it that way. I know from having memorized 13 and 14 that they're between radical 169 to 196. That's not even close to what that amount is. So I wiped that one out. In order to get this one, I simply take 39 times 39, 9 times 9 is 81, 27, 35, 0, 27, 9, 10, 11, 1, 12, 14. So I know that that's square root 1421, and this is looking pretty promising because my number is 1620. So all it needs to do is fit between 1421 and whatever 42 is. 42 squared be 4, 8, 0, 8, 16, 4, 16, 7, 1764, and it does fall within there. 1764. So that tells me that is my answer right there, because I converted this back to being a square root, and I converted all these to square roots. Okay, can you simplify the radical expressions? Again, tree factor, break it down to primes. Doesn't matter how you tree factor, if you're doing it accurately, you'll come up with the same primes that I do. And now we look at the factors in there, and we get anybody out of prison we can. There's 2 2s, bring them out. Nothing else can come out, so there's our answer. I'm going to run through these quickly. I would suggest that you pause the video, you solve them, and then you come back and check my answers, see if you have them right. Those that you don't have right, see if you can figure out what you've done wrong. And if you can't, then make sure and ask a question in class. On this kind, I never ever multiply them up. I just go ahead and factor them down, expand them, and then I take out the number that I can to get them out of prison. Which I guess you could have looked at that and said they're twins. They could come out like that. And then the final answer would be 8. And on this one, 50 is equal to 25 times 2. And I already have a 25 there, so I figured don't break them down. Just go ahead and pull that 25 out. If you can easily see what can come out of prison, do that. Okay, down to our final little section. X to the 8th. Well, if you expand that out, you've got 8 x's under there. Those two wipe out to bring out 1. Those two wipe out to bring out another. Those two wipe out to bring out another. Those two wipe out to bring another. We get x to the 4th outside of prison. Nobody's left inside. H to the 3rd. Those two come out. That one's left in. This one expanded out would be 3 x's in there. Those two come out. And we have 1 left in. Here you can see that we have twin x cubes. Let's just go ahead and bring one of them out. If you wanted to expand it, you'd have 6 x's in there, and you find that 3 could come out. Here you break down the number. That's 2 times 5 times 5, x times x times x, y times y times y times y times y. And that's our expansion. Now we bring our twins out. There's 5 on the outside. 2 has to remain in there. There's 2 x's, so we can kill them off, get 1 out, and 1 stays in. 2 y's, bring that set out. Another set, and now there's 1 that stays in. Now we need to bring this back together so that we have y squared, so it's 5xy squared, radical 2xy. And that's the end of the taping for this section. Thank you very much.